Hey everyone, let's talk a little bit today about navigating and running programs in RStudio. Um, and we're going to start with the um, terminal. So RStudio has an R console, which is essentially a terminal that is already running R, so you don't even have to start it. And this will allow you to type in commands at the command line. So we could do something like create a text variable that is all of the lines from the text file that contains Dickens's Oliver Twist. Okay? And I can even print that out. It's going to only print out the first 1,000 lines, which leaves a lot out. But I can tell it to only show me the top of the file, the head. This is by default the first 6 lines. Okay. If I want to analyze Oliver Twist for the most common words, I can type a series of commands in. I can first split everything up by space so that I get each separate word in its own little container. We'll talk more about containers later, but all right. Let's look at text and see what it looks like. That's the nice thing about working at the command line is that you can interactively, after you run each command, just check and see, okay? So the first line, we've got something like 10 words, and the second line, we've got 7 words, and the third line has 0 words, and so on and so forth, all right? But I don't really need to keep which line is which once I've got the words. So I can get rid of the nested line and word within the line structure that I have before, and just get a big long list of the words. If I want to go over here to the environment pane, I can see that now my text item has 163,381 entries in it. That's kind of a lot. A little bit hard to think about. So I could define a table that just counts up how many times each word appears. Okay. And if we look at that, we can see that we've got a bunch of blank words. We've got underscore I underscore. We've got dash dash apostrophe. These are not, words that I would have expected to see. So what we might do is sort the word freak table. Can't type. Okay, so we're going to sort our table by the number of occurrences. And we're going to make sure to do that in a decreasing way so that we get the most common words at the top. And then that looks a lot more reasonable. So the is the most common word in Oliver Twist. So far, so good. We can print this, the first 10 lines of this out by just doing that, or that, okay? These are equivalent commands. All right, so that's how we would analyze Oliver Twist interactively in the R console. Now, if we wanted to do that for a bunch of different books, it would be really inconvenient to have to type all those commands again. So instead, we go through and we record all of these commands in a script. That's cool, right? And then we've got everything recorded, and we actually have specified that we can take an argument from the command line. That's what this does. That is where the file is located, so that we can run this same set of commands for each file that we might want to use. Okay. Awesome. Okay, so let's figure out how to run this script from the command line. All right. So to do this, we actually need to go to the system terminal. Okay. I'm going to apologize that my dogs are probably barking in the background, so sorry about that. All right. So we run this script from the system terminal, okay? But before we do that, we have to navigate to the proper folder. Which I can do with the cd command on Linux. If you're on Windows, the dir command is what you would need to use. You also need to know the path from where you are to where you need to go, which I kind of just typed out based on this little tree here. So I was in projects, which is here. So I just had to go into several different folders to get to where I have stored the files, right? Then to execute my script, this words.r, I use the command rscript, the name of the file with all of the commands in it, words.r, and then I have an argument. So I can type in Dickens Oliver Twist, or I can type in the first few letters and then hit tab, so that my tendency to type too fast and misspell things doesn't bite me. All right. So running this gets me a little warning that says I'm ignoring where you usually run commands from. That's fine, no big deal. Not all warnings are meaningful. And then we get the output of all of the commands that we ran in sequence just a minute ago. We just get the end result, all right? So that's cool. We can do the same thing, incidentally, with the Python script, okay? So instead of our script, we would say Python 3 on my computer, maybe Python on yours, words.py. And then we pass in the file name. Well, okay. So this is a difference in how the two scripts are written. The Python script doesn't take the argument at the command line. Instead, it asks you for the file name. So I provide that, and it spits out that the most common word is the with 8,854 occurrences, right? So that's how you would run scripts at the command line. Notice that how you invoke the script, the initial command differs between languages, that how the script is constructed determines whether you pass the argument in when you invoke the script, when you run it, or after you run it as a interactive sort of argument, right? So that's a little different in Python. We could probably do that in R, but different languages have different conventions for how you do things, and really different things are easier in one language over another. And I think that's probably the biggest reason that the Python script is different than the R script in that particular way. Okay? All right. So another way we could do this and do this same basic analysis is to run this code interactively, right? So to do this, we have to modify the words.r. So I'm going to create a new file, paste things in. When we're running things interactively, we don't take arguments from the command line. Instead, we would just put our file name in here. Okay. And so to get from one line, or to execute a single line, here, I would use Control or Command on a Mac and enter. And you'll notice that down in the console, the line gets copied, which indicates that it's been run. So I can move to the next line and run that. I can highlight just a piece of the line and run that, which will show me what is currently in text. So I can move through this and look at different pieces of my data after I've run different commands. I can sort things and then look at it again. Right? But at the end, the result is the same, right? So how we invoke the command, how we run the script doesn't change the actual results, right? I can similarly modify this Python file and create a new Python script, and instead of input enter file, I can just define what file I want to run, right? Okay. So when I run the first line of a Python file, what I actually see is a line of R code that says reticulate REPL Python. Okay, cool. I get a message saying we're going to use a different Python than what you set it to because yada yada. None of that is that important for what we're doing now, though that is useful information for debugging. And then you see the three greater than, less than signs, which indicates that something is being run in Python. Okay, and what was run in Python is this command name equals Dickens Oliver Twist. So over here, you see that we're in Python. We have some Python data. One variable is name, and it has this value. There's another variable here called R. And what that does is it gives us access to all of the things that were defined in our R session within Python. So there's some automatic magic here that happens to allow you to work with R and Python and kind of move back and forth between them. None of that really matters for what we're doing right now, right? So just as in Python, or just as in R, in Python, we can use Control Enter or Command Enter to move line by line through the file. Unlike in R, Python cares about white space. And so if you want Python to finish with a block of code that's got some indented stuff, you have to actually give it a new line before it will finish that, even in interactive mode. So that's kind of an important difference between the two. If we select a set of lines and run those, that extra inline automatically gets entered. And then you can see that we get the same result in Python that we did at the command line. Right? So none of this is actually changing the results. It's just differences in whether you have to input the file name at the command line or whether you change the file name inside the file with all the commands in it. The big thing that you need to recognize, though, is realizing when you're in Python and when you're in R. So there's a Python logo up here that says I'm running in Python. The command prompt characters are different. If we want to exit Python and go back to R, we type in exit, and you'll notice that the command prompt changes from 3 carets to 1. So being familiar with the different ways that you can tell whether you're in Python or R will save you a lot of time. The final way that we can interact with this code is using literate programming. And so the words.qmd file in here is a Quarto markdown file. Quarto is a program that allows you to have code and text all in the same basic text document that is not very pretty formatting wise, but has very simple ways to indicate formatting. So like this would be bold. This is a third level heading. This is a code chunk. So it has 3 backticks and then the programming language that you're working with. And it ends with 3 backticks. That's what sets code apart from text. Okay. Quarto also has nice ways to be able to say, okay, I want to show this code, but I don't actually want to run it. Or in this case, echo false means I want to show the output, but I don't actually want to show the code in the final document. This can be really useful when you're printing out results from a model or something like that. You don't necessarily want to show all the code you used to get to the model, but you want to show the output and the model values, right? So if we look at our words in R example, you can see I've added a lot of text, kind of adding some context to what we're doing. This is a nice thing about literate programming is that you can have all of your documentation right next to your code. So there's not a whole lot of looking back and forth or trying to find the relevant part of the help document for a particular program. Also, you'll find as you're writing your own programs, it's pretty uncommon to take the time to write a help document to understand a program that you wrote just to complete a task, right? You're more interested in completing the task than you are in writing the documentation. Quarto allows you to kind of split the difference here. So just as when we were working with an R script, we can run code line by line here using Control or Command Enter. So this has all of the benefits of having everything in a script with some additional benefits because you can add commentary or some narrative or all sorts of different things around your code to make it useful, right? So we can also run a whole chunk by clicking on the little play button here. That's also fairly nice, though my general preference is to not use a mouse. All right, so the trick here, and the reason I'm getting an error though, is that I need to make sure that I run all of the chunks, well, because running them out of order can cause errors. All right. The nice thing about Quarto is that the render button runs all of the chunks from the start completely from the beginning in a separate environment. So there are stronger guarantees that everything is working when you render a document than when you run code chunks interactively. That is something that Jupyter, which is the Python sort of equivalent to Quarto, doesn't do, and is the reason that we use Quarto in this textbook. All right, so you can see that compiling this document into a web page, an HTML file, gives me pretty well-formatted headings, gives me nice links, right? So I can get to my source file here. I don't think I can actually get, yeah, I can get back by just hitting the refresh button. And so you can see the code and the output from that code. You can even copy the code from the document back into the file. Hopefully this looks familiar because the textbook is written in Quarto and has these copy things that allow you to easily run the examples, right? Now, Quarto is really nice because you can also include Python chunks. So I've done an example of all of the Python chunks as well. And you can see that the output is the same. All right, so Quarto files have a lot of the advantages of scripts, have a lot of the advantages of being able to use things interactively. They're not ideal for like automating something where you just want some process to run periodically and say fetch data from a website or something like that. That is better done with an actual script. But anytime that you're actually trying to produce something to show to somebody else, Quarto is much better than having an R script and copying and pasting things. So hopefully that makes it a little easier to navigate through the differences between using a terminal and using a script and using literate programming to put all of your code in a place that makes sense to you. All right, thanks.